Hello YouTube. Well, we've got another change of venue today. I'm in my little machine shop and the plan for today is I want to make a spring compressor. I said we were going to have a look at this shock in a bit more detail. Now the first thing I need to do is take this spring off so we can look at dismantling it and rebuilding the shock. So in order to do that we need a tool to compress the spring. Obviously, I've told you I'm not an experienced mechanic and I'm most definitely not an experienced machinist. In fact, I actually sell timber for a living, so what made me think I could do videos showing people how to work on bikes is beyond me. But here goes, hopefully you're enjoying them. If you are a machinist, I will apologise in advance for some of the things you're going to see. So, I've had a rummage around. First thing I've found is a bit of 10mm alley plate, and we're going to use that for the top. And I found a nice big solid chunk of aluminium, which conveniently is just the right size to fit in the bottom of the shock. The NC23 shock is a bit unusual. It has a clevis on the bottom. Most bikes, they tend to have these eyes, these bushes, top and bottom. So that works out quite well. I also managed to get myself some more engineer's blue. Got myself a new tin of it and I thought I'd try it. Got a little bit carried away, painted all this face, and actually we're only going to drill one hole in it, so I could have just marked that area. But there we go. So the other thing we've got is some 12mm threaded bar. I'm not really a fan of this stuff. It's very low tensile strength. But I'm hoping using 12mm bar that should be strong enough for what we need. Obviously I'm going to be very, very careful when I first use it, or whenever I use it in fact, to make sure that it's up to the job. So let's throw nuts all over the place. Right, let's make a start. So I've marked out this bit of bar, and the idea is with a hole saw I'm going to cut out this central section, about 60mm in diameter. We're then going to put it on the milling machine and I'm just going to mill out a circle just recessed by about 2mm, and the idea is that it then locks against this part of the shock and stops it moving from side to side. So we're going to machine that out and then we're going to drill two holes, 65mm or 130mm apart, 65mm from the centre. They're going to be 12mm, and that's what we're actually going to clamp down. Ideally I would have liked something a little bit bigger than this. These holes are a bit close to the edge for my liking, but it was all I had. So I've marked all that out, done that traditional way with just a pencil and an old compass set. So now I'm going to mark out the same holes on this. So I'm just going to zoom you in a little bit and we'll start marking out. So we're going to have two holes in the top, 65mm from the centre line, and then one hole in the bottom. So the block itself is 32mm in diameter, or in width, so we need to mark out the centre line of the block of wood. Unfortunately, I need to put my reading glasses on. Now, in case you're wondering about these vernier calipers, they were a normal, relatively cheap set of vernier calipers, but I actually dropped them and I smashed the end off here. So rather than throw them away, all I've done is, using the bench grinder, I've just ground them down to a point. But they do, which now gives me a reasonably accurate tool for marking out. Okay. So the total length is 170mm. So that is going to be mental maths, 85mm. So there's the centre of the block, and I'm just going to punch it. If you get the first punch a little bit off, you can just, this is one of those automatic punches, and you can just angle it to get it where you want it. Make sure you get back on centre. So there's our centre line, and I'm just going to set the compass up 65mm. And these are where we're going to drill the holes that the bar is going to thread into. I'm also going to drill 2 more holes and tap them to M6, because what I want to do is put some L-shaped brackets on here at a later date so that I can do conventional shocks as well. So I'm going to make those 35mm apart. Right, so that's those marked out. Okay, and then the other thing we need is we need a 10mm hole. It's going to go all the way through. Now I'm going to put that on this about 15mm down from the top. In fact 16mm, because we're already set up for that. So just going to mark that. Okay, so that's all marked out. This is already marked out. So what we're going to do is I'm just going to switch you off for a minute, and then we're going to move over to where the drill press is. Right, it would appear the battery didn't want to last long enough to show you the whole thing. So I've drilled all 4 holes, and now we're going to go back and drill these 2 middle holes out to 5mm, ready to be tapped. Then the outer holes, I'm going to drill them out to, again, be tapped for M12. The reason I've drilled them out to 4mm and then gone out to 5mm is it just minimises any distortion in the hole. So because it's a tapping hole rather than a clearance hole, I want it to be nice and accurate. Unfortunately it does mean a bit of faffing around changing things. Again, just got to reset the depth gauge to 25mm. So the next thing we're going to do, I'm going to drill these two holes out in a couple of stages, out to 10.2 millimeters, ready to take a tap. So I think you've seen enough drilling for a while, so I'll be back shortly. Welcome back. Well, I've threaded the two 12mm holes. They took quite a bit doing, and I'm quite glad that I'm only actually threading them into aluminium. I'd hate to have done it in steel. Okay, so we've got these two 6mm taps. So I've got a bit of an unusual tap here. It's a spiral tap. Now the theory with these is you don't need to back them off like a normal tap. You can just keep going. Unfortunately, I think this one is starting to get a little bit worn, so I am going to just back it off every now and again. You can see just a bit of WD-40 and just a couple of turns on the tap, back it off a little bit, and eventually we should feel it bottom out. And there it is. So that's our first hole tapped, or third hole as the case may be. We've already done the 12mm holes. I've just got to tap the final hole. So while you were away, I also drilled the 10mm hole through there to take the actual shock absorber at that. Right, so that's that block finished. Now we're going to move on to this one. So what I'm going to do first of all is I'm going to drill these 3 holes, and then we'll move you over to the milling machine. Okay, so I've drilled the 3 holes in this to allow me to bolt it onto the milling machine. A milling machine is basically a very heavy duty drill, and it uses special cutters like that, and you can machine in straight lines. So you've got the head here, and you can move the tool up and down just like a pillar drill, but also you can move using this wheel and this wheel, you can move the bed backwards and forwards in your X and Y planes. So what we're going to do is mount this plate on this device here, and this gives us an additional bit of movement. It's called a rotary table, and it allows us to move the piece in a circular motion, so we can actually cut out a slot around here. So I'm just going to zoom you in a little bit so you can see the machine a bit better. And we're going to mount the plate to the rotary table. Now I've already centred the rotary table in the mill, and I've locked these carriages off so they don't move. So what we've got in the middle of the rotary table is a little pin, and using this pointer I'm able to just check everything lines up. Now this is the bit where real engineers are probably going to throw their hands up in despair, and it's how I'm going to mount this on the rotary table. So I've got two little T-pieces that it bolts to. And again, the piece in the middle also has 6mm thread, so if I bolt the plate into there, I know that that hole there is centred on the plate and the spigot is centred on the rotary table. Just tighten these Allen bolts up and clamp it firmly in place. Now I think this rotary table was handmade by a previous owner. I'm just going to do a double check, make sure the pointer lands in the middle, but we may need to do a little bit of fine adjusting on the table because this is there or thereabouts. So now that I've got the piece centred on the machine, we're going to take the pointer out and replace it with the cutter. Now this may seem a bit violent hitting it with the hammer, but the actual tool is held in on a tapered collet. So the way of releasing the collet is just to give it a gentle tap with the hammer, and there's a threaded bar at the top here that I'm just going to tighten up. Which then draws the tapered collet up into the shaft and tightens everything up. Quite an old-fashioned way of doing it. More modern machinery actually has collet holders that you can undo with a C-spanner. So now that we've got the everything in place, I'm just going to loosen off the lock on this table here, and we're just going to move it across until we get the tool in the right position. Now normally you would measure all this and count the number of revolutions on the handle. The problem is I inherited this machine and it's all calibrated in thousandths of an inch. I of course work in millimetres. So for something like this it's not that critical. I can just work to the pencil marks, and that's what I'm going to do. So I think we're about there. It's certainly close, and we're going to have to do 2 passes anyway because the cutter isn't wide enough to do everything in one. So let's fire up the machine and we'll start our first cut. you can see we've cut an arc, and I actually got it bang on first time, more by luck than judgment. So as you can see, there's a little bit of play in this rotary table. I've never actually used it before, so I'm going to carry on cutting. I'm just going to take some very, very light cuts. I'm not going to go in too heavy with it. So, apart from a bit of chatter on the table, which I'm going to have a look at and adjust out, quite happy with that. What I am going to do now is just move the table towards me a bit, because I want to make it a little bit wider than the cutter. So we've come in about half the width of the cutter, and we do the same again. Okay, so that is the recess cut out. And now all we've got to do is cut the centre out with the hole saw. Okay, so you can see the plate fixed to the pillar drill. Hole saws are pretty evil things. There's quite a lot of force going on, so there's no way I was going to try and hold it. So I'm using this clamp. So let me stand over here. Okay, we're finally through. Now you watch this on other YouTube channels and they whiz through these in seconds. Clearly not the case today. Just a bit of rag. That's hot. But the key thing is, we're through. And if we just check it for fit, happy with that. So the only thing left to do is I'm going to drill the two 12mm holes, or drill these holes out to 12mm. We'll assemble it and then I will come back and we'll see if it works. Here we have the completed assembly, the shock absorber compressor, all fitted together quite nicely, and now let's see if it actually works. Obviously got to make sure that I tighten up the bolts evenly. So far so good. Hopefully it won't launch itself through the ceiling of the workshop. And that's enabled us to gain access to the little snap ring that holds the whole shop together. Quite worrying, isn't it, that that one little bit of metal is all that keeps your spring in place. And there we have one shock body ready to be dismantled. So looking at it, the shaft all looks pretty clean, but I'll be looking at that at a later date. So that was it for that little project. I hope you enjoyed it, something a little bit different. And yes, in the meantime, I suppose I better get on with clearing up all the swarf out of the workshop and get back to cleaning the rest of the suspension components. Until then, I'll see you soon. Thanks for watching.